Hello and welcome to Maths with El Profelo, doing some elementary number theory using a textbook by James K. Strayer. In the last video, we talked briefly about the fundamental theorem of arithmetic, and that states that every integer greater than 1 can be expressed as a unique product of prime numbers raised to positive exponents, right? So we have p sub 1, p sub 2, p sub n are distinct prime numbers, and a sub 1, a sub 2, a sub n, these superscripts, these powers, are positive integers, okay? So for our practice, we want to use prime factorization to find the greatest common divisor and the least common multiple for each pair of integers, okay? So once again, what we are able to do here is show how technology can be efficient for us. So we'll say the least common multiple of 108 and 168. All right, this will give us really everything that we need to be able to check our answer and to be able to check our work. So what are we expecting to see? We're expecting to see you explicitly write out that 108 is given by 2 squared times 3 cubed, and that 168 is given by 2 cubed times 3 squared times 7. Okay? Now, if I'm going to find my least or my greatest common divisor, let's do that first, right? I am going to search for the items that are similar here, right? I'm going to search for the items that are similar, and this should be a 1. All right, so these prime factors that are similar, and select the one with the least. So here and here. All right, and the one with the least would be there, and the one with the least would be there. So we'd have 2 squared times 3 to the first, which is 12. Okay. I'm going to just rewrite this factorization so that it's easier to show the notation. And if I want to find the least common multiple, all right, if I want to find the least common multiple, I am going to look and say, hey, you know, if I think about this as being here 7 to the 0 and there's 7 to the first power, that I want the highest power for each of my prime factors. So that's going to be 2 cubed, 3 cubed, and 7 to the first. So this is going to be 2 cubed, 3 cubed, times 7 to the first. And if we multiply that out, we should get 1,512. All right, and of course, we can come over here and just double check that that is true. We'll say 2 to the third power times 3 to the third power times 7, and there is that 1512, okay? So fairly straightforward. Of course, when you have technology, it makes it a little bit easier to do, but this is what we would expect to see from you, okay? Should be able to find these factorizations on your own as well. That's for another time. Okay, so now let's come over here and let's say that we wanted to just look at the prime factorization to help us with our next numbers, right? And we'll say we have 267, or no, excuse me, 450 and 325. So we set that up. And we see our factorizations, right? And so the factorization, and there's different ways that you can write this out. Let's see here, prime factorization. Oops, that's why I can only do it one at a time, be careful. All right, so prime factorization of 450 is 2 to the first power 3 to the second power 5 squared, all right, of 325. Adjust this. Okay, for 325, what do I have? It looks to be, nope, that's just 32, 325. For 325, that prime factorization is 5 squared times 13. So that means that my greatest common divisor, I need to select the smallest power of items that are alike. So I don't have a 2 in both of them, don't have a 3 in both of them, don't have a 13 in both of them, but I do have a 5 squared in both of them. So that greatest common divisor is going to be 5 squared, and that's 25. All right, and then my least common multiple of 450 and 325 is going to be given by, if we set this up, right, we want the highest power for each. So 2 to the first, 3 squared, 5 squared, and 13. So that's 2 to the first, 3 squared, 5 squared, and 13. All right, and if we multiply that out, all right, we can come over here, all right, and say, 2 to the first times 3 squared times 5 squared times 13. We get that our value is 5,850. Of course, right, we know that we could use our technology to check that out. So least common multiple, right, of 450 and 325. All right, so different ways that you can write this on the computer, and we do get that it's 5850. Okay, so we'll pause there and let you try out 267 and 1121, and we'll go through that on our next video.